Alright, so welcome back. This is the scenario we're in, and we're expected to calculate these four scenarios. So let's begin. I think I'm gonna clear my workstation a bit. I might just erase a question. So sorry. Um, Alright, so let's see. So what we're gonna look on ice. So let's write it down. So scenario one, we add ice. We're at minus 20 and we're moving to 0 degrees Celsius. So that should have been that. And we're saying since we have a change in temperature, we're gonna use this equation. Need to convert. Give me a second. I should have my calculator. It's not open. So let's see what we know. We know the mass here. The mass is 20 grams. Let's convert that into kilograms by dividing that by 1,000, and we'll end up with 0.02 kilograms. We have our specific heat capacity of ice as being 2090 joules per kilogram per Kelvin. And what else we know? Our change in temperature, we're going to have 0 to minus 20, and that will give us 20 kelvins. We don't want a negative energy, so we want that to be a positive number, nevertheless. So let's put that in to get the heat energy needed to raise the temperature of ice at negative 20 to 0. So that's going to be 0.002 times 2090 times 20, and we'll actually have that in joules. So that is equal to times 2090 times 20. We end up with 836 joules, and that is for that portion there. I should use this button. No, I don't want to come off this page. All right. So our next portion we'd want to look on is scenario 2. If you didn't remember what scenario 2 is, we're gonna change the temperature. We're gonna have a change of temperature. So scenario 2, we're at ice and it's melting. The ice was melting. Therefore, this is a latent heat question. And since we're moving from a solid, melting from a solid to a liquid, is gonna be specific latent heat of fusion. So let's look at that. So that's going to be EH, heat energy, is going to be equal to the mass times the latent heat of fusion. So the mass, we just converted that to 0.02, and the latent heat of fusion of ice is 336,000, and that would be a constant given to you by CXC, so you don't have to worry about that. And let's put that in our calculator, and we end up with 6,720 joules. Are we finished? No. So we're just only at 0 degrees because ice is going to melt at 0 degrees. We need to move from 0 to, we're going to move from water from 0 to 100. There is this. Number 3. So we're going to have water, and we're moving from 0 degrees Celsius to 100 degrees Celsius. And once more, we have a change of temperature. So we're going to move to that equation. Heat energy is equal to the mass times the specific capacity times the change in temperature. So we know the mass of that is 0.02. The specific capacity of water, more likely to be given to you, is 4,200. And your change in temperature is going to be 100. And let's do that and put that in your calculator. Oh, I just got it wrong for some strange reason. And times 100. And we end up with 8,400 joules. Now, the last portion said we reach steam. So we know that after liquid water reaches 100, it's going to reach steam. So we have to look at that. I guess we erased the question by accident, but we know the question. Alright, so let's look on steam, what's happening there. Fourth scenario. And that's going to be, we're going to implement some problems though. Alright, fourth scenario, we're going to end up with this here. And that's going to be latent heat of, vaporization. Keep on writing fusion. And that's going to be 0.02 times the specific latent heat of vaporization of steam. This constant should be given in the question, so we don't have to worry about that constant. And we multiply that there. Put that in my calculator. Give me a second. That's 26.1. All right. We end up with 452,000 joules. Now, the question asks us for the total heat. So the total heat energy needed. So let's answer the question. Total heat energy needed would have been equal to, we add up all those. So right now we have these in front of us. We have the 8 plus the 40. Give me a second, I'll bring up the rest. Alright, so we'll enter ahead and bring up the other two from previously. So let's add up everything there. And we end up with this as being our answer. So to move from negative 20 ice to reach 100 degrees Celsius steam, that's the amount of heat energy we need to move 20 grams. So pause the video, we're going to look and give you one question to do, and we're going to move on.